Today we are focusing on the study of short-term memory. Short-term memory is defined as a memory system that retains information for a brief period of time. The study of short-term memory all began in 1959 with Lloyd and Margaret Peterson. They were interested in discovering how long participants could remember a string of 3 letters when rehearsal was prevented. 24 participants were chosen to recall 3 strings of letters. They were then asked to count backwards in 3s or 4s to prevent rehearsal. They were asked to recall the 3-letter strings in intervals of 3 seconds. The Petersons found that the longer the interval delay, the less 3-letter strings were recalled. After 3 seconds of delay, participants were able to recall about 80% of the strings. However, after 18 seconds, participants were only able to recall 10% of the strings. This study shows that short-term memory has a limited duration if rehearsal is prohibited. The Petersons added an interference to their experiment. Interference is a loss of information from memory because of competition from additional incoming information. In an experiment conducted by Gary Jones and Bill Mackin, participants were tested to observe whether they could remember digits or words better. The results found that participants could recall digits with more accuracy than words. In our experiment, we decided to test whether it was the time or the interference that affects short-term memory. We are focusing on retroactive interference. Retroactive interference is the interference with retention of old information due to acquisition of new information. Many experiments have been conducted to study the length of short-term memory. However, our experiment will bring a deeper and new understanding to the study of short-term memory. This experiment addresses the question of short-term memory when presented with an interference. Participants include a random sampling of Santa Clara University freshmen that will have signed up for the study. We will table at Benson to make sure any first-year student at Santa Clara can sign up. We will tell them that they will get a minimum of $5 for just participating and can earn up to $50 additional dollars, for a total of $55 during the study to give them an incentive to sign up. The study includes 300 students in total, including 150 males and 150 females. We will randomly assign the 300 participants into 3 sections of 100 randomly assigned groups. Each group will be taken into a different classroom, but the classrooms will all be identical to avoid any extraneous variables interfering with their performances. The students will sit in front of a computer to begin the study. An experimenter will enter the room and tell the students about the procedures of the study without giving any clues to the purpose. They are told to begin. A series of 3 letters will pop up on the screen. For example, the series B, P, K will be shown on the screen. All 300 students will be shown the exact same series of letters. The letters will disappear from the screen after 3 seconds, and a timer for 10 seconds will begin. During those 10 seconds, the interference is introduced to the study. The members in the control group, Group 1, will not have an interference. They will be looking at a white screen for the 10 seconds. The members in the experimental groups will receive interferences, but the difficulties will vary. Group 2 will be shown an easy number pattern that they must solve. For example, the series 6, 8, 10, 12, 14, blank will be shown on the screen. Group 3 will be shown a difficult number pattern that they must solve. For example, the series 15, 29, 56, 108, 208 will be shown on the screen. The students will have a space to type in the answer to the pattern. After the 10 seconds are up, the screen will go blank. Another page will pop up for all the groups and ask the students to type the letter series they were shown. The same process will be repeated 10 times with a new letter series every time and a slightly different number series. The number series will be the same level of difficulty within each group. For example, Group 2 will consist of basic adding or subtracting,
but Group 3 will consist of more complicated multiplication and division. Each time, the accuracy of remembering the letter series will be recorded.
The control group will consist of the students who receive no interference. Group 2 will consist of the students who receive an easy interference, and Group 3 will consist of the students who receive a hard interference. The independent variable is the interference. We will manipulate the appearance of a number pattern, as well as the difficulty of the pattern. The dependent variable is the accuracy of remembering the letter series. The remembrance depends on the degree of the interference. Each student will be taking the test on a computer. All belongings will stay outside the room, and they cannot use the computer for other uses to avoid distraction. The students will be spread out around the room so that no one else can see any other person's screen except their own. Every student will be given 10 seconds to complete the task. It is very important that the time remains constant so we can focus on the difficulty of the interference. The participants know that they will already receive $5 for just participating. They will also be told that they can earn an additional $50 throughout the study. We will tell the participants in the experimental groups that they will receive $2 additional for recalling the letters, and $3 additional for solving the sequences. However, to make the experiment fair, we will pay all the groups an additional $50 at the end of the study because it is not fair for the control group because they do not have the option of gaining the $3 additional per round.
We predict that the accuracy of a student's short-term memory will decrease as the difficulty of the interference increases. To test this hypothesis, we will compare the accuracy of remembering the letter series between the students who received no interference, the students who received an easy interference, and the students who received a hard interference. We will then compare the means of each group to see which group, as a whole, remembered the letter sequences correctly and more accurately.
In our study, it is crucial to follow the procedures exactly. We emphasize the importance of exactly 10 seconds for each round because we want time to be a constant factor. Another strength is that our study is different from any study done before. We're taking a slightly different study and modifying the conditions, specifically the level of the difficulty instead of time, to find out new information. However, there are a few limitations and weaknesses to our study. First off, it is important that the students are unaware of what group they are put in and they do not realize that we only care about the accuracy of the letter series and not the number pattern. Second, the incentive can cause unfairness between groups. Even though we're going to give them the same amount of money at the end, at first it seems unfair to the control group because they do not have the opportunity of gaining as much money as groups 2 and 3. Lastly, because everyone has different math skills, students might have different ideas of what is classified as easy and as hard number patterns.